Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is hydrogen and its compounds, heavy water and isotopes. Whether you are gearing up for NEET, JEE or your school exams, mastering this topic will definitely give you an edge. Let's begin with the most basic element in the periodic table, hydrogen. It's the lightest and simplest element, consisting of just one proton and one electron. Hydrogen is incredibly abundant in the universe, especially in stars and gas giants. It is also a crucial component of water, acids, and many organic compounds. But what makes hydrogen even more intriguing is the presence of different isotopes, which leads us to our next discussion. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. Since isotopes of an element have the same number of protons, they share the same chemical properties but may have different physical properties, such as mass. Hydrogen, being such a simple element, has three important isotopes: protium, deuterium, and tritium. Let's start with protium. This is the most common isotope of hydrogen, and in fact, it makes up around 99.98% of all hydrogen in the universe. Protium consists of just one proton and one electron, with no neutrons. Because of its lack of neutrons, it's the lightest hydrogen isotope. When we talk about hydrogen in most chemical reactions, we are typically referring to protium. The second isotope is deuterium. Deuterium, often denoted as D or superscript to H, is a stable isotope of hydrogen that has one proton and one neutron in its nucleus, in addition to one electron. This extra neutron makes deuterium about twice as heavy as protium. Deuterium is found naturally in small amounts, making up about 0.015% of all hydrogen on Earth. Deuterium plays an important role in various scientific and industrial applications. It's used in nuclear reactors as a moderator in the form of deuterated water or DO, which leads us to our next topic, heavy water. Heavy water, or DO, is water in which both hydrogen atoms have been replaced with deuterium atoms. As a result, heavy water is denser than regular water. While it looks and behaves similarly to regular water in many ways, heavy water has some unique properties due to the difference in the mass of the hydrogen isotopes involved. For instance, because deuterium is heavier than protium, the bonds in heavy water are slightly stronger, and the physical properties, like the freezing point and boiling point, are slightly different from those of regular water. Heavy water is used in nuclear reactors, especially in certain types of reactors like the CANDU reactors, which are used in some countries for nuclear power generation. The reason heavy water is used in nuclear reactors is due to its ability to slow down neutrons without absorbing them. This is essential for sustaining a chain reaction in a nuclear reactor. The use of heavy water as a moderator allows reactors to use natural uranium as fuel, which is not possible with regular water. Although heavy water is essential in the nuclear industry, it's not something that we encounter in our everyday lives, largely due to its cost and limited availability. However, it's a great example of how an isotope of an element, like deuterium, can give rise to a compound with unique properties. Moving on to the third isotope of hydrogen, tritium. Tritium, symbolized as T or superscript 3H, is a radioactive isotope of hydrogen. Tritium has one proton, two neutrons, and one electron. Tritium is rare in nature and is primarily produced in nuclear reactors. Unlike protium and deuterium, tritium is radioactive and decays over time, emitting beta particles. Because of this radioactivity, tritium is often used in various applications such as in the production of luminous paints, in nuclear fusion research, and in some specialized instruments that require a radioactive source. What makes hydrogen and its isotopes particularly interesting is their role in various chemical reactions and processes. For instance, deuterium is sometimes used in research to trace the movement of atoms in molecules, especially in biochemical studies. By replacing the hydrogen atoms in a molecule with deuterium, scientists can track how the molecule behaves without altering its chemical properties. This technique is widely used in studying chemical reactions and even in drug development. Another fascinating aspect of deuterium is its presence in the form of heavy water in biological systems. Although heavy water is toxic to living organisms in large quantities, the small amounts that naturally exist in regular water do not pose a significant threat. The presence of deuterium in water is a reminder of the variability in nature and how different isotopes of the same element can lead to different properties and behaviors. One key takeaway from this video is the importance of hydrogen and its isotopes in various industries, from energy production to scientific research. Whether it's protium in fuel cells, deuterium in nuclear reactors, or tritium in research and technology, hydrogen isotopes are fundamental to many modern technologies. By understanding their properties and applications, you can appreciate how chemistry, even at the atomic level, impacts our everyday lives and the technologies that shape our world. So, to wrap up, hydrogen and its isotopes, protium, deuterium, and tritium, are fascinating and highly relevant to various fields of science and industry. From the water we drink to the nuclear reactors that power our cities, hydrogen plays a crucial role in our world. Heavy water, with its unique properties, demonstrates how small changes in atomic composition can lead to significant differences in behavior and application. Whether it's for energy production, scientific research, or even in the study of biochemical processes, hydrogen isotopes offer endless possibilities. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.